How did you do? Oh my gosh. Algebra 2, Common Core, the second coming of crazy exams. Guys, girls, boys and girls, anybody across New York State, this is the Thursday, August 18th exam. I want to first apologize for not getting this out quicker. I wasn't teaching summer school this year because I was working on a project with a colleague of mine. By the way, all of these can be found at our website at www.n. That stands for Newman. K, that stands for Krause. And you know, of course, infinity stands for the length of your favorite class, mathematics. But anyway, that's our project that we've been working on all week. So I didn't teach summer school this year, and therefore I was not privy to some of the exams nor the grading material. I still don't have the grading material for this exam. But it was given yesterday afternoon, so anybody that had extended time or was to continue teaching should be done by now. I know there's some strange stuff going on in our school, so I wasn't sure, and I still haven't gotten a hold of the key, but I believe I have all the right answers. Although there were a few weird questions on this one, I had to check with a colleague of mine just to make sure that my brain was functioning correctly. And you know, we're sponsored by Dunkin' Donuts. Now, of course, we don't get any money from them, but they're sponsoring me. They're sponsoring me by keeping me awake. By the way, if you haven't taken the time to subscribe to my YouTube channel, to our YouTube channel, please do so. Hit that subscribe button. Helps me out. My name for the next 30 minutes. Now, because this is going to be used by future students to take the January exam next year and the June exam next year and so on and so forth, I will be trying to do a little bit of teaching while I'm going over this. So this is going to be part one, problems 1 through 12. Okay? If you're just here for the answers, I guess you can scrub through, but if you want to know how you did, you can go slower. All right, here we go. Let's go. Let's get moving. Some problems were easy, some problems were not so easy. Which equation has a solution that is 1 minus I? So what I would like to do is show you a couple of different ways to solve this. 1 minus I means it has imaginary solutions. So first thing I'm going to do is just use the quadratic formula on it. A is on all these. Yeah, that would be kind of hard. But notice all the numbers are the same pretty much. There's only a couple of differences. So let's do this first one. This is choice 1. A is equal to 1. B is equal to 2. And C is equal to negative 2. Now remember, if it's going to be imaginary roots, that means my discriminant, b squared minus 4ac, which is about to come, has to be less than 0, or in other words, it has to be negative. So my d, which is my discriminant, is b squared minus 4ac. So if this is going to be true, it's got to be negative. So let's see, b squared is 4 minus 4 times 1 times negative 2. Now, if you were to type this in your calculator, that would give you 8. This would give you positive 12. Because that's positive, it can't be choice 1. All right, so let's try choice 2. Choice 2 says the only difference is this is going to be positive. That's choice 2. So b squared is 4 minus 4 times 1 times 2. This would be, let's see, this would be 4 minus 8. This would be negative 4. So this is a possibility. Choice 2 is a possibility. So let's try it. Let's see what we get. X equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now that's the quadratic formula. A lot of times they put the whole thing over 2a. I just choose not to. So this is going to give me x equals. Now negative b is negative 2 over 2 times 1. Plus or minus the square root of negative 4 over 2 times 1. Well, this is x equals, this is negative 1 plus or minus. Now this, remember, this is 2i here. So 2i over 2 is just I. So this gives me negative 1 plus or minus I. Not exactly what I want. I want the positive 1. Now, in order to get this to be positive 1 right here, that means this would have to be negative, and that is this choice right here. And if we went through and used the quadratic formula, that would be the probable answer. Now, how can I use my calculator to help a little bit? Well, at least I can narrow it down. Like, for example, especially if I just like lost my head and can't guess, let me put in choice 1, x squared plus 2x minus 2. X squared plus 2x minus 2. Enter. That's got real roots. See how it hits the x-axis? Those are real roots. Now, B, or choice 2 had this as a positive. Notice how it doesn't hit the x-axis. That one has imaginary roots. Choice 3 is negative, negative, so we'll do choice 3, tab. Delete, minus, enter. That one hits the x-axis, so that has real roots, so that can't be the right answer. And finally, the last one, tab, hit this. I'm going to change this to a plus. And I notice it doesn't have, so it has to be either 2 or 4 just based on the graphs. And then you can use the quadratic formula to do that out. And in fact, just based on the graph, all I would have to do, because this piece right here is just negative b over a, over 2a, all I would have to do is, okay, negative that, negative 2 over 2 times 1, is that going to give me positive 1? No. How about this one? Negative 2 over 2 times 1. Is that going to give me positive 1? Yeah, that gives me positive 2 over positive 2, which gives me my positive 1 as my answer. Couple of different ways to solve that one. All right, you want another way. Let's do it one more time. So I think this is my right answer. So I told you this is a teaching video, so if you don't want to learn a couple of different ways to do it, by all means, get out. We're going to go menu, 3, 3, 1. We're going to use polytools. But notice I don't want real solutions. I want complex solutions. Complex means a real number and an imaginary part, an I part. So I click OK. And I say, okay, what were my numbers? I think it's choice 4. 1, negative 2, 2. 1, negative 2, and 2. And I click OK. And I click OK. And there, 1 plus or minus I. And I can use that calculator just the same way. Okay, so that's 3 ways to do that problem. Expecting an email, and I got a weather alert. Yay, that was useless. By the way, I apologize for the look of this graph. I used my home scanner, and it doesn't appear to be scanning very well. I got a nice line in the middle. So let's go through this one really quickly. Which statement about statistical studies are true? So this is one of those SAT type questions where you got Roman numeral 1, Roman numeral 2, Roman numeral 3, is there Roman numeral 4, and Roman numeral 4, and then you got to decide which ones are right. Okay, so let's see. A survey of all, and words like this are important, all English classes in a high school would be a good sample to determine the number of hours students study throughout the school spend studying. Wow, this is why I teach math, not English. Well, if you test all English classes, and if you think about it, doesn't everybody have to take an English class? I mean, everybody. Even if you're an ESL student and you're taking English as a second language, you still have to take an English class. So everybody has to take it. That's why and you got all English classes. So that looks like that probably is a pretty good choice. That one looks like a pretty good choice for a good statistical study. But this is one of those ones where we got to pick some that work and some that don't. A survey of all 9th graders in the high school would be a good sample to determine the number of student parking spaces needed in high school. First of all, if you're a 9th grader driving to school, I don't need to say anything. So probably not a good indicator of how many parking spaces you need, because you might have one 9th grader in your school that drives. That's probably not going to happen. So, even if it was 11th and 12th graders, well, then maybe that would be good. But no, not a good choice. That doesn't make any sense. A survey of all students in one lunch period would be a good sample to determine the number of hours adults spend on social media websites. What? So you're going to ask kids in a lunch. First of all, it's just one lunch period. So you haven't even, as soon as you start limiting it to like one specific group or one specific period, you already know that's a bad way to collect data. So that doesn't make any sense. First of all, who's asking kids what their adult parents are doing on social media? You don't want to know. I don't want my kids to know. I mean, not like, check stupid videos on, but, nobody wants to know that stuff. A survey of all calculus students. So these are the brains. If you're in those classes, good, because you're going to rule the world. Brains in the high school would be a good sample to determine the number of students throughout the high school who don't like math. What? Why would you ask calculus kids about kids that don't like math? First of all, again, you restricted it to one specific group. And as soon as you restrict it to one specific group, you introduce this thing called bias. And bias is what every statistical research and data collection is trying to avoid. And if you can avoid bias, which is virtually impossible, but if you can do everything you can to avoid bias, you've got a good statistical data, which this is not. So the answer to this one is just one only. Is that it for that page? I believe that's it. All right. Okay, we're off to part 3. If you haven't watched my videos much, you know I have to take breaks every 10 minutes. Otherwise, my sounds just slightly off. You'll notice at the last minute or so of that last video, notice my audio was just slightly off, and that is annoying. So anyway, let's try this one. We want to know to the nearest tenth of a value, the value of x that satisfies this equation. Now, if you tried to do this one algebraically, you're probably not going to be very successful. If you try to do it by plugging the answers in, it might work and it might not. So let's try 2.5. Let's just try 2.5. 2.5, control var x. And we press enter. And on the left side, we type in 2 raised to the x. Now, you can't put equals because these are rounded answers. So never do that anyway. 2x, put in the left side, put in the right side, plus 11. Huh. Okay. So they're close. They're close. 5.6 and 6. They're close, but they're not real close, but they are close. Let's try 2.6. Control var x. Enter. Oops, I forgot the x. I didn't forget it. It just didn't register. Come on, baby. X. Enter. Then we'll highlight 2 to the x. And we'll see that's equal to. Okay. And then we'll highlight negative 2 x plus 11. Well, those are close too. So these are close, 5.6 to 6, and these are close, 5.8 to 6.1. These appear to be a little bit closer. And these would be really bad. So that's one way to do it. This is the right answer. But how do you do it for real, for Rizzle? Okay, what you want to do then is go over to your graphing calculator. We're going to graph both sides. So I'm going to graph 2 raised to the x and hit enter. And then I'm going to hit tab, and I'm going to graph negative 2x plus 11. And I'll press enter. You'll notice that they hit. Remember, the solution is the point of intersection. So we're going to go to menu, analyze the graph, and we're going to go point of intersection 4. And all we do is click here, and you'll notice the x value is 2.55. So what value of x? Well, x equals 2.55719, which rounds to 2.6. All right. So the lifespan of a 60-watt bulb produced by a company is normally distributed with a mean of 4. Okay, so as soon as I hear the words normally distributed, I'm going to see if I can hopefully you can read this. Normally distributed. I'm going to bust out my normal distribution curve. That's not bad. Actually, it's pretty good. Hopefully it's like a hat on my head right now. There's my normal distribution curve with a mean of 1450 and a standard deviation of 8.5 hours. So I can subtract 8.5. I'd get 141.5, and over here I would get 1465. Well, I want to know from 1440 to 1465. Really? No, it's not 1465. Why did I put 1465 there? It's 1458.5. So it's 1458.5 because I have to add 8.5. I added 8.5 here, and I subtracted 8.5 here. Now, these numbers, wait, this should be 1441. These numbers here, I mean, this is close. This is close to 1440. I went from 1440 to 1465. But even if I added another standard deviation, it's not a half a standard deviation. It's not a it's not. So it's one of those ones where you're really just going to want to come over, and hopefully your teacher taught you how to do this. You're going to want to come over to your calculator. Let me get rid of this. And you're going to go into Menu, Statistics, Distributions, and you're going to do Normal CDF. Now, the way normal CDF is, the lower bound goes here. Well, they wanted 1440 as our lower bound. They wanted 1465 as our upper bound. The mu, which is the population standard deviation, was 1450. Excuse me, the mu is the mean, and sigma is the population standard deviation, which they told us is 8.5. So really all you had to do is put in the meaningful data, and they will tell you what the area under this curve is. That's what the normal CDF works. And you click OK, and it says 0.8414. So 0.84148899, which of course is choice 3. Okay, so my goal is to teach you how to take this test, how to use your calculator effectively, and how to use your brain even more effectively. So number one, first of all, highlight words like this, because I don't know what it is about the Algebra 2 Common Core. They insist on introducing the word incorrect, not going to happen, oops, you screwed up, didn't see that not word, did you? It happens all the time. So really get in the habit when you take your Regents exam. If you've already taken it, I apologize, but if you take your Regents, highlight incorrect. So we're looking for the one that doesn't work, because for those of you that think, oh, which one works? Yeah, this is the difference of two squares, which this is perfectly correct. That one works. So if you didn't see the word incorrect, you're like, ooh, that one's factored correctly. Bam, done, bodied. Wrong. Now, how can I do it graphically? Can I do these graphically? I absolutely can. Doc B gets rid of that. So I just go into graph mode, and I type in the left side, 4x squared minus 49. 4x squared minus 49. Yes, I know it has a different letter. It doesn't matter. And you get some graph. You know it's a parabola if you want to look at it, whatever. Then you hit tab, and you type in the right side. Parentheses, 2x plus 7, parentheses, 2x minus 7. Now, I don't know if it said minus 7 plus 7. Doesn't really matter. And as long as it matches it, watch the blue, it's going to disappear, and it becomes red. It's the exact same graph. So that one worked. So let's try the one that doesn't work. The one that doesn't work is this one. And this is the right answer. So if you tried to factor this, and I'm going to show you algebraically how to do this. So m cubed plus 3m squared. Because you're going to have to show your teacher that you tried something. So I'm going to try to factor this by grouping. I'm going to group these two together. I take out an m squared, and I'm left with m plus 3. I take out a negative 4, and I'm left with m. By the way, this should be minus. Oh. Well, this will be m minus 3. because when you take a negative 4 out of these, I was just looking at it, you take a negative 4 out of this, it doesn't even work. But let's just say you even didn't do that. You thought this was, by the way, this would be the right factoring, equals 0, and you can't do anything after this. You're pretty much stuck. But let's say you accidentally said, oh, that's m plus 3. Well, then you would end up with m plus 3 times m squared minus 4. And m squared minus 4 would be m plus 2 m minus 2, not that thing. But even still, let's check this sucker out graphically. We'll doc B, we'll get a fresh graph, go away, hit a fresh graph, and it's going to be, let me look down here. We got to use x cubed, get out of cube mode, plus 3x squared, plus 3x squared, minus 4x plus 12. I have no idea what this thing looks like. There it is. I don't care. That's not at all what it looks like, but it doesn't matter. As long as, now for the most part, it really doesn't matter. I mean, I could grab this thing. Oh, there's what it really looks like. All right, there's a better graph of it. There's what it really looks like. So now let me hit tab. I'm going to put the right side on there, which was m minus 2 squared, parentheses, x minus 2 parentheses squared, parentheses, x plus 3. And that's what they gave us. Now, if it matches it, we're good. It's not even close. Not even close. The blue one's over here. The red one's over there. It doesn't match. There's the right answer. So there's two different ways to solve that problem. By the way, if you factored this last one just for fun, because you probably should show work, this one is t cubed plus 6t squared plus 11t plus 6. Does this sucker factor? Let's see, if I take out a t squared, I'm left with t plus 6. And plus, I can't take anything out of that, so I'm just left with 11. That doesn't even factor. So the only way you'd be able to do that one is if you triple distributed all this over here. It's easier just to do graphically. For those of you thinking I'm taking forever, I apologize. Remember, this is a... By the way, if you're doing... I always forget about this. If you're actually just sitting here watching the performing monkey going, oh my God, he's so good. I love his bald head. He's such a... You know, seriously, you're wasting your time. If all you're doing is here to watch the performing monkey work, you're wasting your time. You should stop the video now, do this problem on your own, and then see if you get the right answer. And then if you get the right answer, you're great. If you got it for the wrong reason, fix your answer. But if you got it for the right reason, hey, great. If you have no idea how to do the problem, then come watch the bald performing monkey. All right, so the other thing the Common Core likes to do is to put a lot of words in a lot of problems. Guys, that's reality. When you're working through math problems in the real world, there's going to be lots and lots and lots of words, and you're going to be working in projects with other people where you have to explain yourself. So get used to it. So Halley's High School is planning their spring musical. The revenue, how much money you're going to make, there's a vocabulary word, the amount of money that you're going to make, can be generated by this function, where T represents the price of a ticket. The production cost, C, of the musical is represented by this function. What is the highest ticket price to the nearest dollar they can charge if they want to not lose money? Okay, so this should be at least a little bit obvious what you're going to do. You're going to take the revenues and you're going to subtract the cost. So how much money you bring in, but minus how much money you got to pay. And in order to not lose money, I have to be greater than or equal to 0. So I just need to subtract these two things. So that's what I'm going to do. Negative 33t squared plus 360t minus... And that's the hard part. Did you remember to put parentheses? Minus 700 plus 5t. And we know that has to be greater than or equal to 0. So let's do this math. That's not behind my head. Negative 33t squared plus 360t minus 700 minus 5t has to be greater than or equal to 0. So I get negative 33t squared plus 355t minus 700 has to be greater than or equal to 0. All right, so now that I've got this equation, I've got this equation right here. I'm going to use that equation. I'm going to grab my calculator. And I'm going to say, okay, I'm going to say let t equal 3. All right. 3 control var, and I'm going to actually use t since I'm not doing it graphically. I can do 3t. And so negative 33 t squared plus 355 t minus 700. Enter. Hey, 68 bucks. Look at that. 68 bucks. Sweet. So you're thinking, hey, I'm done. I made money. It's greater than 0. I'm done. I wonder if we are. Let's try it again. The next one is 5. So 5 control var t. Now the cool thing is, oops, sorry. The cool thing is, I don't have to type that long line in again. What? Control var T, hit enter, and then I just hit this up arrow until I highlight that line again. Oh, $250. Okay, that's not bad. And then, what did you say? 8. Control var T, hit enter, and then hit the up arrow. Boom, 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 boom. Enter. 28. What? I made money there too. Holy crap, what's going to be the right answer? So the last one is 11. So 11, control var T. See if I can make money on all these. Enter, enter. Oh, negative $788. So negative 788. So that price, I lost money. I made negative money. So that's not going to work. So now I've got 3 positive answers. So it's a stupid question. The question should read, in which ticket price, what should I set the ticket price at in order to maximize my profit? So I don't know why they didn't ask that, because that would have been a much better question than this, because then you could have just taken this thing and found the maximum and then set the ticket price to there. That's not what they said. What they said was, what is the highest ticket price to the nearest dollar they can charge in order not to lose money in the event? So this is one of those ones I was waiting to see what the state's answer should be. Because if I'm doing this problem, and let's go graphically on what they should have asked on this problem. Doc B, sorry about that. It's negative 33x squared plus 355x minus 700. Now, this is going to be a wreck because it's not going to be anything like I see, but I know it's there. I know it's an upside down parabola, so I know for a fact somewhere way up here is going to be the top of this thing. I just can't see it. I don't even care. I just know up here somewhere there's going to be a maximum. So what I'm going to do is I'm going to go Menu, Analyze Graph, Maximum, click here, and I go, oh, my maximum is $5.37, right? So the maximum is at $5.37. I'm going to make $254, but you can't set a price at $5.37. So if the question was worded correctly, if the question was worded the way I think what they were looking for, choice 2 would be the answer. However, this question was not worded correctly, and this is why I was waiting for the answer key, but I never got it. The way this question is asked, and again, it's a stupid question, what it says is, let me highlight it for you. I'm going to highlight it for you so you know where my dilemma is on this one. What is the highest ticket price to the nearest dollar, which is why would I care about the nearest dollar? Because I just got to pick these 3 answers. They can charge in order not to lose money in this event. So we made $28 here. Now, based on these 3 answers, I would say the answer is 8. Now, maybe what they were looking for, by the way, this is where I make the most amount of money. So I'm not sure why I would want to overcharge my customers and make less money than charge my customers an appropriate amount and make more money. See, that's a dumb question. But maybe what they were looking for, and let me go back to what this thing was. Maybe what they wanted you to do is find this root or 0 here, because this is where I start at when it goes from being above here to where it goes down here. It's where I stop making money. So I make money, lose money, make money, lose money. So I make money above, lose money below. So maybe what they're looking for and what they want to do is analyze the graph, and they're looking for a 0. Click here, and say, oh, 8.15. And so that's why the answer is 8. So if the state was correct, and they should be, this should be the correct answer. If you chose choice 2, I apologize. It's not a very well-written question. Got some cool stuff in it, but not a very well-written question. So choice 3 should be the right answer. Every time I take a break, I hit the Dunkin' Donuts coffee. Oh, it's so good. I'm not going to be able to sleep tonight. Anyway, the set of data in the table below shows the result of a survey of the number of messages that people of different ages text on their cell phones each month. So, age group from 15 to 18, from 19 to 22, and from 23 to 60. Well, that's a big range. I wonder why they would do that. And their messages for the month. So we got this crazy data chart. This is actually a relatively easy question. If you saw one thing. If a person from this survey is selected at random, what is the probability the person's text over 50 messages? Now, if you just saw that, you might want to think, oh, let me add all of these up. No, because the second part of the question is very, very important. Given that the person is between the age of 23 and 60. When they say given, then what they're saying to you is don't look at any of this. We are not going to look at this. Given means whenever you see the words given, that means, hey, you can only look here. And then you say to yourself, okay, if I add all those up, I get 229 people. So all of the people in the range from 23 to 60 is 229. How many of them were over 50? And that would be this number right here, 157. So the answer to this question is 157 over 229. The recursive formula, blah, 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 blah. So notice, cut in half. So if it's recursion, these are not recursive formulas. They're just geometric sequence formulas, and that's not a recursive formula. So notice they both start out with 18. Okay. And I am taking 18 and cutting it in half, 9. Cutting it in half, 4.5. So this would be the right answer. And you could go over to your calculator, and if you haven't seen recursion on the calculator again, what you do is you put 18 in your calculator, enter, and then you're going to type in just this formula, 1/2 times the answer. Now, n-1 just means the one before it. And that's what we're doing with recursion. So we do 1 divided by 2 times the answer. And the answer is this 18. Click enter, 9. Click enter, 4. Well, that should be 4.5. Enter, and blah, and so on and forth. So choice 8 is the right answer there. Moving on. Number 9. Kristen wants to increase her running endurance. According to experts, a gradual increase of 10% per week can reduce risk of injury. If Kristen runs 8 miles in 1 week, which expression could be used to find the total number of miles she would run over the course of a 6-week training period? Kind of similar to the last question, sort of. So what we want to do is increase by 10%. Well, remember, that's 100% of what she's doing now plus 10%. Okay, so that's 110%. Now, as a decimal, that's 1.10, which leaves this one out. Doesn't make any sense. And quite honestly, if you just typed in this one, it wouldn't make any sense either. So also it says, what is the total number of, and generally, these sometimes work, but not in this case. So what I'm going to do is I want to increase her total number of miles she'll run over the 6 weeks. So we're going to start at 8, and we're going to increase by we're going to increase by 10% every week. And what's the total amount of miles? So if Kristen runs 8 miles in week 1, that means when I type in 1, I should get 8 out. So I need to type this in and verify that I get 8 out when I type in 1. So I'm just going to type in that part. 8, parenthesis, 1.10, parenthesis, raised to the 1 minus 1. Again, I'm plugging in 1 for n. Oh, I get 8. Okay, that would say in week 1 I got 8. Now let's check this one right here. This one kind of makes sense. So 8, parenthesis, 1.10, raised to the 1. And that says, oh, 8.8 in the first week. That doesn't make any sense. So this one doesn't make any sense. So by the way, you're thinking, well, maybe I should check these. Why not check them? It doesn't matter. If in the first week you did 8, and the second week you did 10% more, that'd be 8.8. And 10% more of that, what was that? That's add 8. So now let's add 0.9. What was that? 9.7. And we're going to go 10 point. This one's probably close to 11. This one will probably be close to 12. This is probably close to 14. I don't know. Add them all up. I should get an average of about 10. This should be somewhere around 40 miles. I don't know exactly. I knew, no, if I type this in, it's exactly. But let me type in this one. Let's just see what I get. So control division. 8 minus. Let's see if it's even close. 8 parenthesis 1.10 raised to the 6th all over 0.9. Oops. Come on, baby. Go down. 0.9. Negative? Negative? Don't think so, brother. And we already got rid of this one. So that's why the answer is 1. All right, moving on. The sine function increases through a sine function increasing through the origin. Okay, so what we're talking about is a sine function increasing through the origin. Sorry. So that means it's something like this. Something like that. Can be used to model light waves. Violet light has a wavelength of 400 nanometers. Now, a wavelength is the time. Where is it? That's the period. Or in other words, so in this case, it's 400 nanometers. What that means is it takes, what period, remember, is the time it takes to finish one full curve. So if we said a wavelength is 400 nanometers, that means to finish that one full wavelength, one full curve is 400. That means to finish half of a curve, it's 200 nanometers. Or to finish here, then would be 100 nanometers. Or here would be 300 nanometers. Makes sense, right? All right, so that's just the basics of the problem. Let's see what's going on now. Over which interval is the height of the wave decreasing only? All right, well, decreasing, we're looking for coming down. So now we're looking to see when is this thing coming down. It starts coming down here and stops here. So from 100 to 300, not including those, because including those is kind of like the turning point. Was decreasing, now it's increasing. Was increasing, now it's decreasing. So from 100 to 300, choice 2. Okay, children, in my endeavors to help you out, do a couple of different problems a few different ways, I'm going to show you method 1 to do this problem, which is the proper way to do this problem, and that would be long division. Or you can use synthetic division, but I'm going to use long division. I like long division. So x plus 2 is my divisor, and I'm going to divide into x cubed plus 2x squared plus x plus 6. Now, the reason I'm doing it the right way is so that I can get the right answer, so that I can show you what it looks like and how it's going to behave when we go cheat a little bit. Okay, so I decide how many x's go into x cubed. Oh, x squared. So x squared times x is x cubed. X squared times 2 is plus 2x squared. I bring out my big subtraction button. Subtract, subtract. I end up with 0x squared. All right, plus x plus 6. You still need two things down here because this is just nothing. So then you say to yourself, how many times does x go into x? Once. So plus 1. All right. 1 times x is x. 1 times 2 is 2. Bring out my big subtraction button. 6 minus 2 is 4. So my answer is x squared plus 1, that's this part, plus 4 over the divisor x plus 2. That's that remainder theorem that you learned this year. That's the remainder theorem. All right, whatever the remainder is goes over the divisor. So the answer is choice 2. Now, how can I cheat? All right, let me show you one way to cheat. It's not cheating, it's using your tools to help you solve. By the way, okay, it's also using your tools to check your answer. So let's take any value x. Now, I'll take 2.13. It doesn't matter. Don't pick like 5 or 4, 2 or 1. Never pick 1 or 0. But pick something weird. The calculator is going to do all the work anyway. So I do control division. And my divisor was x cubed. Or my numerator was x cubed plus 2x squared plus 2x squared plus x plus 6 plus x plus 6 all over x plus 2. And I hit enter. Some weird answer, right? But my answer was x squared plus 1 plus control division 4 over x plus 2. Same answer. Okay, that's another way to do the problem. Let's move on. Oh, this will be the last problem for this page. Oh, and of course it's a statistics question. So, all right, this is another question I didn't very much care for. I think it was worded poorly, and I don't think it's a very good statistics question. All right, so let's just see what we got here. So a candidate for political office commissioned a poll. His staff received responses from 900 likely voters, and 55% of them said they would vote for the candidate. The staff then conducted a simulation of 1,000 more votes of 900 voters, assuming that 55% would vote for their candidate. The output of the simulation is shown below, and it should be normal. We got a relatively normal distribution curve. I mean, if you were to look at this thing, it's relatively normal. But that's not really that kind of helpful. So we want to figure out what percent of error would give us a, where's my problem? Oh, what percent of error would give us a 95% confident interval? So 0.1 is just way too low. I mean, 0.1 would be from here to here. Would you be 95% confident? No. 95% confident is really working on the tails. Remember, if you've got a normal distribution curve, 95% confident is really 2 standard deviations. Maybe I should have done those in a different color. 2 standard deviations from the mean. So if this is my mean, 95% confidence interval will be 1, 2 standard deviations. 1, 2 standard deviations. So what should be my percent error to capture 95%? Or in other words, we want to look at the middle 950 over 1,000, right? Would that make sense? 95%. So I need to capture 950 of these. Or in other words, I need to lose 50%. So if I picked 0.1 or 0.01, excuse me, that would be from here to here. Does that lose? These are all lost, and these are all lost. Is that losing only 50? No, it's losing a ton. So that doesn't even make any sense. If I use 0.03, well, that would be here to here. Am I losing 50? Well, that's like, that's a little more than 50, but that's not bad. That's not bad. I'm going to leave that one as a possibility. That's a possibility. We know that's not a possibility. How about 0.06? So if I take 0.06, 55, and I add 0.06, that's 0.61. That's right here. And if I subtract this, I get 0.49. That's right here. Well, that's everybody. That's everybody. That's like 100. You'd be 100% confident based on that. So that's too much. And wait, that's too much too, because that's going to go like 0.12 and 0.12. That's going to be way out here. That's way too much. So if I was to create my percent error to be 95% confident I would say 0.03, even though I think maybe 0.04 probably would be a better answer, but 0.03 would be pretty good. Okay, that's it for that problem.